Hello, this is LJ Henderson. I am your gem of STEM. Yes, GEM is an acronym that I use. I am a girl educating the multitudes, and I'm super excited that you're ready to have a STEM-tastic time with your students in your program. So what I'm going to do today is to demo some of the things that you'll find in our teacher resource kits. And we also have student kits as well. So the first kit that I'm going to talk about, if you have it, is our human anatomy kit. Our human anatomy pretty much will cover different concepts at different times. Some of the materials may change from time to time, but there will be some things that are standard. For example, your kit will always have a human anatomy body figure, a 3D body figure that you'll actually be able to manipulate organs with your students. Sometimes they're smaller, sometimes they're bigger, but it will always be one of these so that your students can actually see the different organs that are in the human body. One thing that you want to do when you get your human anatomy kit is to look at your discovery guide. So your discovery guide is pretty much your resource to tell you and explain to you step by step how to do our experiments. We want to make STEM easy for you, low prep, and easily engaging for your students. So as I discussed, you will have a human anatomy, not just a poster, but you're going to have an actual human body to use. I put the poster in here just so that you could see some of the different body parts, and you can choose which ones that you want to go over with. What I do for a lot of my teachers is to have them expand on the different organs. So you could spend a week talking about the heart, you could talk about the lungs, you can talk about the brain. It's your choice. Right now we're just introducing the students and we want them to label. When we get into the experiment part, we're going to identify the 4 blood types. This will be standard with all of our kits no matter when you purchase it. So in this, you'll actually get to set up a miniature lab just on a table or anywhere in your classroom that you see fit. If you have a STEM lab, that's amazing. We'd love to see it. If not, you can do it on a table, and I'll demo that today. So you're going to multiply this number of cups for your students. So I always do 16 when I'm doing small group. All of our experiments are meant for small group. I would recommend no more than 5 students at a time, but you can do as many as you like. But the contents of our materials are pretty much used for small group instruction. No more than 10 students. Ideally, I would say 5. So you'll take out your cups, you'll label each of your cups. You'll have 16 cups. For the purpose of this, I'm only using 4. You'll label each of your cups A, B, and O. And what are those? Those are the 4 blood types. So you're going to duplicate that, so you'll have 4 A's, 4 B's, 4 AB's, 4 O's. In this, for little kids, we want them to identify that there are 4 blood types. So that's how we're going to address the math in STEM. Now they're actually going to do something with STEM. What they're going to do is actually a chemical reaction kind of experiment. So they're actually going to mix these chemicals together to actually determine which blood types are compatible. So if the colors stay the same, then the students would know that those blood types are compatible. If the blood type changes or if the color changes when they mix them, then they know that those blood types are not compatible. So by doing this simple experiment, the students will be able to determine which blood types are compatible. So let's try it, why don't we? So here's A. So I would give it to a student and I would call them up one by one and let them. Do you think you can mix A with B? If you mix A with B, because I'm sure you know if you mix A with B, you're going to get AB. So right now, this is going to get darker. So can A blood type donate to B? No, because those colors changed. Can O donate to AB? Yes, the colors did not change. O can donate to AB. Can O donate to A? Yes, the colors did not change. Now, O can donate to A, but can A donate to O? What do you think? No, those blood types are not compatible. So by doing this experiment, if you remember, O was a clear liquid. If you put clear into any one of these, nothing's going to happen, and that's because O is a universal donor. All of the directions of the things that I just explained will be in your discovery guide, and students will learn that O is a universal donor. They also will learn different patterns. So you could do A, B, take your other cup, and actually let them practice an AB pattern, because that is one of our state standards for students to actually understand patterns. So we can use science to address our math standards as well, just by going over the different patterns. So that's one thing you could do in your discovery guide with your human anatomy. We're also going to get to make edible DNA. Super simple. You can use Twizzlers, you can use dots, candies, you can use straws. All the instructions are in there. There will be some very high level vocabulary in this particular experiment, so we will actually use the real words and tell them about the 4 nucleotides and which ones pair together. There's 4 key vocabulary words when we talk about DNA. So it's deoxyribonucleotide is how you pronounce the word. Deoxyribonucleotide. That is the technical term for what we affectionately call DNA. So DNA is pretty much our makeup of our body, how we get our hair color, our eye color, and this is what we explain to our students. We will use technical vocabulary with them. So for the younger students, we just want them to know that there are 4 different nucleotides, and what are those? Adenine, thymine, cytosine, and guanine. And the way that I like to do it, adenine starts with what letter? A. Thymine starts with what letter? T. I tell them that A and T go together. At. A and T go together. At. So adenine and thymine, they pair together. So those are the 2 nucleotides that pair together. The other one is cytosine and guanine. So I always say, because cytosine starts with a C and guanine starts with a G, we park the car in the garage. So that's how they'll remember which ones pair together. And it explained that to you. So for this particular lesson, we just want the students to be able to identify that there are 4 nucleotides and which ones pair together, reinforcing that math skill. Then we get to do a pumping heart experiment. Now I'm going to move this out of the way while I demo, because sometimes the teachers have a hard time with this one. You're going to take a balloon. You want to stretch it out.
You already did it.
I'll just pour some red in here.
Yeah, because it's not even a pure cup.
This is actually the pumping heart experiment. I'm going to demo this to you really quickly just so that you see. So pretty much for this one, you're going to demonstrate exactly how the heart pumps blood. So you'll have 2 cups. You'll cut the neck of the balloon off, like so. Then you want to stretch this part of the balloon over the cup. All right, so you stretch the balloon over the cup. So that's how you do it. Make sure that it's nice and tight. You want to make sure that it's nice and firm around the cup, as you can see. Sometimes you may have to practice with the balloon multiple times, like I had to do. I think the closer that you cut it to the neck, the better. So then that way you don't have to think about the little small part trying to go over there. But pretty much I did it. Now you want to puncture it with the toothpick. Now this is the part that you have to make sure that you don't make it too wide. So you're going to puncture a very small hole with a toothpick in the balloon. So it's in there. Now, here's the trick. You have to put the straw in the same hole that the toothpick was in. You don't want it to be too wide, because if it's too wide, it's not going to create a suction action. And that's what you want to do. So it's a very tiny hole, but we're going to have to stretch it. This part can take a little time. What I like to do, I like to use plastic straws because they puncture better. And if you can fold it, like the little tip of it, find that hole and gently work it in there. Again, you want it to not be too big, because if it's too large, then it's not going to create that suction. So let's see if we can get it in there. Now this is where you have to have patience. It's going in, going in. So as you can see, it's going in, but it's going to take some time, because if I just ram it in there, then it's going to stretch it too wide and it's not going to create that suction action that we want. So it's almost in there. Ah, there it goes. Now it's in there. You see that? You see how it's flush on there? That's how you want it. If it's moving around or you could see the hole, then it's not going to create that suction action. So I poured some of the water out earlier because I was afraid it was going to go everywhere. But you want to fill up your cup about halfway full. And the goal is to create a pumping action. Do you see the pumping action? You see the pumping action? Yes. So once you create that pumping action, you will just make it dispense. And that's how the heart pumps blood. So you can get your student, you can count the number of times that it pumps. You can review the number of times that the heart pumps blood in a day to see if you can do that number, which would be an extreme amount. However, you could allow the students to actually count the number of times, again, reinforcing that math skill with this demonstration of how the heart pumps blood. Sometimes we do 2 of them so that we can have dual pumps for the left artery and the right artery, and then we would have 1 cup in the middle. But this gives you a good example of exactly what the students will get to do, and they really get a kick out of it, and they truly love it. So this is how the heart pumps blood. Alrighty. So that was that experiment. So with the pumping heart experiment, that's pretty much all you do. You'll also always get some form of literature or a book to actually read to the students, to review, to learn more about the body parts. You can also do extension activities with this by exploring different organs. You could spend time talking about the brain. You can spend time talking about the lungs. This is just a brief introduction, but you have the autonomy to do whatever it is that you need to do to make certain that your kids learn all about the human body. So think beyond all about me and think about the human body. And make sure that you contact me if you have any additional questions. I would love to see what you're doing with your students. And if you like this particular activity, make sure to send me an email at info@littlestemacademy.com. And if I can ever be of any support to you, or if you're doing an experiment and it's not working out right, if you want to just shoot me a quick email, I'll be certain to get back with you to make certain that we're doing whatever it is to make our kids learn, love, and lead in STEM. Thank you for your time.